Upper explosive limit, and procedure. Safety interview, questions, and answers. Question 1. What is UEL? The upper explosive limit, UEL, is the maximum concentration of a gas or vapor in air that can ignite or explode when exposed to a source of ignition, for example, a spark, flame, or heat. Above the UEL, the mixture is too rich in fuel, gas or vapor, and lacks sufficient oxygen to sustain combustion or an explosion. Question 2. What is the relationship between LEL and UEL? Lower explosive limit, LEL, the minimum concentration of a gas or vapor in air that can ignite. Below the LEL, the mixture is too lean to burn. Upper explosive limit, UEL, the maximum concentration of a gas or vapor in air that can ignite. Above the UEL, the mixture is too rich to burn. The range between the LEL and UEL is called the flammable range or explosive range. Within this range, the mixture is capable of igniting and causing an explosion. Question 3. What are the examples of UEL for common substances? Here are the UEL values for some common flammable gases and vapors, expressed as a percentage of the gas in air by volume. Methane, CH4, upper explosive limit, UEL 15%, propane, C3H8, upper explosive limit, UEL 9.5%, hydrogen, H2, upper explosive limit, UEL 75%, gasoline vapors. Upper explosive limit, UEL 7.6%, acetone upper explosive limit, UEL 12.8%, ethanol upper explosive limit, UEL 19%. Question 4. What is the importance of UEL in safety? Understanding the UEL is critical for preventing fires and explosions in workplaces where flammable substances are present. A hazard assessment. Knowing the UEL helps safety professionals assess the risk of explosions in environments where flammable gases or vapors may accumulate. For example, in confined spaces like tanks, pipelines, or storage facilities, gas concentrations can quickly reach dangerous levels. B. Gas detection and monitoring. Gas detectors are calibrated to measure concentrations of flammable gases and alert workers if levels approach the LEL or UEL. Monitoring ensures that gas concentrations remain outside the explosive range. C. Ventilation and control. Proper ventilation is essential to dilute flammable gases and keep their concentrations below the LEL or above the UEL. In industrial settings, exhaust systems and air circulation are designed to prevent the buildup of flammable mixtures. D. Safe work practices. Workers in industries like oil and gas, chemical manufacturing, or mining must follow strict safety protocols to avoid creating ignition sources, for example, sparks, open flames, or static electricity, in areas where flammable gases may be present. E. Emergency response. In the event of a gas leak, knowing the UEL helps emergency responders determine the safest approach to mitigate the hazard. Question 5. What is the factors affecting upper explosive limit, UEL? The UEL of a substance can vary depending on temperature. Higher temperatures can widen the explosive range. Pressure. Changes in pressure can affect the UEL. Presence of other gases. Mixing with other gases or vapors can alter the UEL. Question 6. What is the practical applications? Confined space entry. Before entering a confined space, workers must test the atmosphere to ensure gas concentrations are below the LEL or above the UEL. Storage tank safety. Tanks storing flammable liquids are designed to prevent vapor concentrations from entering the explosive range. Industrial processes. Processes involving flammable gases, for example, welding, painting, or chemical reactions, require careful monitoring to avoid creating explosive atmospheres. Question 7. What is the regulatory standards? Many safety standards and regulations, such as those from OSHA, Occupational Safety and Health Administration, and NFPA, National Fire Protection Association, require employers to monitor and control flammable gas concentrations to prevent explosions. Question 8. What is the example scenario? Imagine a storage tank containing gasoline. Gasoline vapors can accumulate in the tank, and if the concentration reaches between 1.4% lower explosive limit, LEL, and 7.6% upper explosive limit, UEL, the mixture is explosive. To prevent an explosion, the tank is equipped with a ventilation system to keep vapor concentrations below the LEL. Gas detectors are installed to monitor vapor levels and trigger alarms if they approach the explosive range.